Which statement is true about the halogens going down group 7? So we look at group 7, the trend is CRM, where colors become darker, reactivity decreases, and melting and boiling point increases. So therefore, the answer would be B. Next one, which statement is true for chlorine and iodine? So what you can do is you write down the information of group 7, and you see that for group 7, they have 7 valence electrons, and this will be the colors and the states of chlorine and iodine. So therefore, the correct answer will be B. Next, they're talking about fluorine, and they ask which statement about fluorine is not correct. So fluorine is in group 7. When it's group 7, it means that if it's a covalent molecule, it will be diatomic, F2. If it forms an ion, it will form a negative ion. And if you look at the reactivity, fluorine is always the most reactive. So with this information, the answer will be C. Question number 4, when they say proton number 19, if you look at the periodic table, proton number 19 is referring to potassium with a number of 19 at the top in the periodic table. So if you're talking about potassium and you look at all the statements, it will be option B that is correct. Next question, they talk about reactivity in group 1 and group 7. So group 1 we always remember as Dr. M, DRM, where R reactivity increases. And for group 7 is CRM, where reactivity is the opposite, it decreases. So by looking at that, we will see that the answer would be C. Next one, question 6 asks about group 0. So if you look at the periodic table, group 0 will be this few. Therefore, the answer is A. Okay, and then the next question, when they ask you which electronic arrangement is that for the gas that is normally filled to fill light bulbs. So to fill light bulbs, we always use argon. So you look at argon in the periodic table. If the periodic table will show you 1840. When we write it out, we will write 4018. So 18 refers to the number of protons as well as the number of electrons. So 18 will give you 2.8.8. And therefore the answer would be D. Okay, next, they have given the periodic table here. And to understand this periodic table, first of all, we will write down the groups and the period so that you can understand this better. So accordingly, this is group 1 all the way to group 0. This portion in the middle is known as the transition metals, where there is no group. And this will be the period 1, 2, and 3. So with this information, now we look at the question. The question says, which group do these elements belong to? And the two elements they're referring to is Q and R. So therefore, Q and R belongs to group 7, right, in Roman numbers. And next question, how many electrons do they have in their outer shell? So if it's group 7, the outer shell refers to the valence electrons. So group 7 will have 7 valence electrons. So it shows that Q is on top of R. So therefore, Q will be more reactive. Okay, next one. Which period does R belong to? So if you look at the previous page, R belongs to period 3. Next, how many electron shells does Q have? So Q has 2 electron shells because Q is in period 2. The period number belongs to the electron shells. Okay, what is another name for the elements in this group, which we are referring to as group 7? So group 7, the name of group 7 elements are halogens. Okay, next, we have another question, and again, this question is on group 7 elements. So it says, place these elements of group 7 in the correct order of reactivity. So before we even place them, we know that group 7 is in this order, and the most reactive is fluorine, followed by the rest. So all you need to do is check what elements they have given, and they have given you 1, 2, 3, 4, 5, which is exactly the same as these 5. And then you arrange them from least reactive to most reactive, meaning going from the bottom up. And this will be the answer. Okay, next question. By referring to the electronic structure, explain why these elements are placed in the same group. So again, in the same group means they're all group 7, and in group 7, they will all have 7 valence electrons. Okay, now they ask you to draw a molecule of iodine. And they ask you to draw only the valence electrons. So from what we know, iodine have also 7 valence electrons. It is not possible to draw all the electrons of iodine because it's too many. So we just draw the 7 valence electron. So iodine on its own will be 7 and 7. Molecule of iodine means diatomic molecule, so it's I2. So when you see the lonely electrons being alone, we will then want to pair them up in a sharing, because this is non-metals, which is covalent. So this is how you draw your iodine molecule. This is the answer. Okay, next. Fluorine displaces bromine from a solution of potassium bromide. So what they're trying to say is they're trying to say that I have fluorine and it will displace bromine from potassium bromide. So let's check and see what happens. So if you take a look, fluorine is more reactive than bromine. So when I put potassium bromide and fluorine in a reaction, my fluorine will displace bromide, which becomes potassium fluoride, and bromide being displaced will now be alone and will be on its own bromine. Okay, so that's the word equation. Word equation means we write in words. Next, name another halogen element that will displace bromine. So we need to choose something else that is more reactive than bromine. And what is more reactive than bromine? If you look, chlorine is more reactive than bromine. So which is why we use chlorine. The use of helium is to fill up airships. And we have neon that is used to make lights and advertising signs. The key word you must make sure you write is filling, and making. You cannot just say it's used for light bulbs. You must have the word filling up, and making. That's for 11A. Next, 11B. Explain why noble gases are chemically unreactive. So noble gases are unreactive because one possible way is they have a completely filled valence shell. You can also say that they have either duplet or octet structures. Okay, in this question, they are showing you chlorine with potassium iodide. And before we understand and we decide if there is displacement, we need to check the reactivity of group 7. So group 7, every time when you write this down, the top is more reactive than what's below. So if we look at chlorine, which is added in, chlorine is more reactive than iodine, which is in potassium iodide. Therefore, there will be displacement reaction. So we write out the reaction as follows in words first, where potassium iodide plus chlorine, the chlorine will displace iodine. So now chlorine is with potassium and you get potassium chloride, and iodide is removed and displaced, and it's formed as iodine on its own. So the next question says, write a balanced chemical equation for the reaction. So how do we start writing this balance equation? First of all, using the space at the bottom, we will write the word equation. So the word equation is as follows. After that, potassium iodide is made up of metal and non-metal, so we use the charges of the ions, which is K plus and I minus. Same for this, metal and non-metal, so it's ionic, so we use the charges of the ions. And as the charges of the ions are balanced, so we get Ki and we get KCl because the charges are balanced. Then how about chlorine? Chlorine and iodine both are group 7 elements. So it's an element, it will be diatomic. So you see the Cl2 and the I2. Okay, after that we have to balance the equation. So if you count how many K, how many K, how many I, as well as how many Cl, you realize that you will need to add 2 to this both compounds in front to balance the equation. And with this, you can check your equation once more and you will find that it is balanced. So this is the balanced chemical equation. So this is what we get. Okay, next. They say describe an observation that could be made during this chemical reaction. So if we look at this reaction, what is produced is potassium chloride and iodine. And iodine is a red-brown liquid. So once iodine is produced, we will actually see the color red-brown appearing, and we will say that a brown solution is seen.